In algebra, we use factoring for a variety of things. We're going to use it for a lot this semester. But one reason we use it is it helps us solve quadratics. It helps us find solutions. So let's kind of compare this or relate this to solving other equations. If we have an equation that looks like this, well, we can just isolate the variable. We can add 5, divide by 2, and we get x equals 13. But if we have an x squared or an x cubed or an x to the fourth, we can't just isolate the variable. If I have this, x squared plus 7x plus 12 equals 0, I can't just isolate this variable. So one method that we're going to use to solve this is something called the zero product rule. So let's talk about what that rule looks like, and then I'm going to give you a couple examples. So the zero product rule states this. If something times something equals 0, if A times B equals 0, well then either A is 0 or B is 0. So it sounds kind of common sense. If we have a number times a number is 0, well one of those numbers has to be 0. Or both of them could be 0. So an example of this, let me put it in terms of like what a quadratic might look like. If we have this x minus 2 times x plus 4 equals 0, well, think about what's going to make this true. What value could I put in for x that's going to give me 0? Well, my x could be 2. What value of x could I put in right here so that it's going to give me 0? Well, my x could be negative 4. So that's kind of the foundation of this, is if we have two binomials set equal to 0, we could take this first one, set it equal to 0 and solve. This second one, set it equal to 0 and solve. So like on example 317, this one's actually already factored for me. So if we are just solving it, we have a factor times a factor equals 0. So using our zero product rule, we know this. We know that either 2x minus 3 equals 0, or we know that 5x plus 1 equals 0. One of these has to be true, or both could be true. So if we just solve each equation, if I add 3, I get 2x equals 3. If I divide by 2, I get x equals 3 halves. So one of my solutions is 3 halves. For the other one, if I subtract 1, I get 5x equals negative 1. If I divide by 5, I get x equals negative 1/5. So those are my two solutions, x equals 3 halves, x equals negative 1/5. Okay, but they're not always going to be given to me already factored. Actually, most of the time, we're just going to have a quadratic, and we're trying to find the solution. So we're going to have to do the factoring, which is what we've been practicing this unit. Then we'll have to do the solving. So we've got to decide what kind of quadratic do we have, or what kind of factoring do we need to do the factoring, solve the equation. Okay, so here we have a quadratic where a is greater than 1. So this is where we use either, we can call it the AC method, or factor by grouping. We multiply our 4 times negative 3. We get negative 12. And we've got to think of two numbers that multiply to give me negative 12, add to give me 1. Well, that's going to be a positive 4 and a negative 3. So let's use those to help me rewrite this using four terms. We have 4x squared plus 4x minus 3x minus 3 equals 0. All right, we're going to factor by grouping. Let's group up these two. Group up these two. For my first one, I can take out a 4x, and I'm left with x plus 1. For my second one, I take out a negative 3, and I'm left with x plus 1. So my two factors are going to be x plus 1, and then if I take that out, I'm left with 4x minus 3. All right, so now we are finally to the same point we were at that first problem. They did all the work for us in this first problem. Here we had to do the factoring, but now we just go ahead and solve each of these. We're going to take our first one, set it equal to 0. Our second one, set it equal to 0. So our two solutions, x could equal negative 1, or here I could add 3 and get 4x equals 3. If I divide by 4, x equals 3/4. So we had to do the factoring, set each factor equal to 0, and then solve. Okay, on example 319, notice here we don't have everything set equal to 0. So we've got to move everything to one side first. To do that, I'm going to move this 8x over by subtracting 8x. I'm going to move this over by adding 15. So I end up with x squared minus 8x plus 15 equals 0. Okay, same process here. We need to factor this. Because our a is equal to 1, this is our favorite to factor. All we have to do is think of two numbers that multiply to give me 15, add to give me negative 8. We know they both need to be negative, so I could have negative 1 and negative 15, or negative 3 and negative 5. This one's going to work. So we end up with x minus 3, x minus 5. Here we could write out the two equations, or if we know that this is going to equal 0, this is going to equal 0. Our solutions are x equals positive 3, x equals positive 5. Okay, example 320. This one looks like it's set up for us to solve, but notice we don't have 0 on the end here. And to use our zero product rule, we have to have equal 0. We don't have a -9 product rule, so we need to make sure this is set equal to 0. So in order to do this, I'm going to distribute this left side. I'm going to multiply this, and I end up with x squared plus 3x minus 7x minus 21 equals -9. Now I'm going to move this -9 to the left side, and at the same time, so let me add 9, add 9. At the same time, I'm going to combine these like terms. So I end up with x squared minus 4x. Negative 21 plus 9 is negative 12 equals 0. Now we have a trinomial that we can factor. Again, we actually have a pretty nice one. Two numbers that multiply to give me negative 12, add to give me negative 4. Well, we could have negative 6 and positive 2. So I've got x minus 6, x plus 2 equals 0. Using our zero product property, our x could equal positive 6, or our x could equal negative 2. All right, and then our last couple on this page. This one looks really complicated, but really it's just because we have terms on both sides. So I'm going to try to move everything to one side, and I'm actually going to move it all to the right side because I want to keep my x squareds positive. So let's do minus 3x squared. Let's do minus 4x. Let's do plus 5. Those are all gone, and we get 0 equals 4x squared minus 9. Okay, let's think about our kinds of factoring here. We recognize this as the difference of squares. This is a perfect square, this is a perfect square, and its subtraction. So we can factor it like this. And I'm going to move 0 to the right side just because that looks how we normally see it. The square root of 4x squared is 2x. The square root of 9 is 3. When factoring the difference of squares, 1 is plus, 1 is minus. So when we solve this, we set each of these equal to 0. 2x plus 3 equals 0. 2x minus 3 equals 0. We solve for x on both of them, and we get x equals negative 3/2 and x equals positive 3/2. All right, on example 322, let's move everything to one side. I'm going to move everything to the left side. I end up with 4x squared minus 12x plus 9 equals 0. You may or may not recognize this as a perfect square trinomial. If you don't recognize it as a perfect square trinomial, that's okay. We could factor by grouping. Or if you do recognize it as a perfect square trinomial, the square root of this one is 2x. The square root of this one is 3. We've got to have a minus because a negative times a negative gives me a positive. Negative plus a negative gives me a negative. So really we have the same factor 2 times here. So I've got 2x minus 3 equals 0, or 2x equals 3, or x equals 3/2. So we're combining everything we've done in the last couple sections on how to factor, and now just using those to help us find solutions. Okay, on example 323, We're going to move everything to one side. I'm going to move my 8x to the left side, and I end up with 4x squared minus 8x equals 0. All right, before we do anything, we always look for a greatest common factor. I can take out a 4 and an x. So if I take out a 4x, I'm left with x minus 2. And we're actually done factoring here. We don't have anything left to continue factoring, so I'm going to take each factor and set it equal to 0 using our zero product property. If I solve for x, I get x equals 0 and x equals 2. All right, for these last couple here, we've got to look for a greatest common factor again, just like we did on 323. We've got 2x cubed minus 14x squared plus 24x. We can definitely take out a 2, and they all have an x. If we do that, I'm left with x squared minus 7x plus 12. All right, we've got a nice quadratic to factor inside of here where my a is 1, so those are the ones we like to factor. We're going to keep our greatest common factor on the outside. And all we have to do is think of two numbers that multiply to give me 12, add to give me negative 7. Well, we're going to have a negative 3 and a negative 4. Okay, so notice here we have 3 pieces that have an x. So I'm going to take this one, set it equal to 0. This one, set it equal to 0. This one, set it equal to 0. And this step where you're actually showing the equations, this is up to you guys. If you want to just solve it in your head, that's perfectly fine with me. So our 3 solutions, because we had a power of 3, x equals 0, x equals 3, x equals 4. All right, and then our last one here, we do have a greatest common factor. Again, we can take out a 3 from all of these, and I'm left with 2x squared plus 7x minus 9. All right, we have a quadratic left to factor there. We have an a value that is not 1, so I'm going to use my AC method or factor by grouping method. 2 times negative 9 is negative 18. I want two numbers that multiply to give me negative 18 and add to give me 7. Well, that's going to be a 9 and a negative 2. So let's factor by grouping. We've got 2x squared plus 9x minus 2x minus 9 equals 0. If we continue factoring by grouping, let's look at our first group. I can take out just an x and I'm left with 2x plus 9. Here I can take out a negative 1 and I'm left with 2x plus 9. So my factors are going to look like this. I still have the 3 on the outside. I have the 2x plus 9 that they both have. If I take that out, I'm left with x minus 1. Okay, when I'm solving this, I'm going to kind of disregard this 3 here. There's not a variable to solve for in that piece, in that factor. So we really just have 2x plus 9 equals 0 and x minus 1 equals 0. If I solve this one, I get x equals negative 9 halves and I get x equals 1. So we're going to factor like we've learned using our different methods, difference of squares, perfect square trinomials, where a is equal to 1, where a is greater than 1, and once we have it factored, we use our zero product property to help us find our solutions.